Hello everyone, welcome back to my channel Chemistry. Today we will be practicing few other questions from GOC. Now in this series I have uploaded two other videos. If you haven't watched it, I'll link all those videos in my I button. You can click there and you can watch it. Now let's start this video. So let's start our first question first. The question is, which among the following is the most stable carbocation? And these four are the options here. Now, if you haven't watched my second video, I have explained what is hyperconjugation and how we can describe hyperconjugation, and on the basis of hyperconjugation, how we can decide that which compound is much more stable than the other compound. Now, let's start this video on that context. Okay, so this four system has been given and we have been asked that which is the most stable carbocation. So, we have to find out that this carbon contain the vacant p orbital because this is the carbocation. So, we don't have any alpha carbon attached with this carbon. So, it does not have, because it does not have any alpha carbon, so it does not have any alpha hydrogen. So, it has 0 alpha hydrogen. Moving to the next, option B. In this case, this carbon has the vacant p orbital because it contains positive charge on itself. Now, this carbon is directly attached with another CH3 group. So, this carbon is our alpha carbon, and the hydrogen that is attached with alpha carbon, it is known as alpha hydrogen. So, in this case, there are 3 alpha hydrogen. Moving to option C. So, in this case again, this carbon has the vacant p orbital because this carbon contains the positive charge. Now, this carbon is directly attached with 2 other carbons. One is this one, another one is this one. So, in this case, there are total 6 alpha hydrogen, 3 from here and 3 from here. So, total 6 alpha hydrogen. And at last, moving to option D. So, in this case, again, this carbon contains the vacant p orbital because this contains the positive charge, and this is attached with 3 other carbon that are known as alpha carbon. And alpha carbon contain 3, total 9 alpha hydrogen. So, we can easily understand that which one is the most stable system in this case, because this has 0 alpha carbon, this has 3 alpha this has 0 alpha hydrogen, this has 3 alpha hydrogen, 6 alpha hydrogen and 9 alpha hydrogen. We all know that more the number of the alpha hydrogen that is present in a system, more there will be hyperconjugation and more the molecule will be stable. So, in this case, option D is the right answer. Now, let's move to our second question. So, the question says, in which of the following compound the CCl bond, that's these CCl bonds that exist in these compounds, ionization shall give the most stable carbonium ion. Now, what is ionization? So, in this case, they are asking that after bond breaking, this CCl bond breaking, that's what they are expecting us to understand by ionization. So, by ionization of this CCl bond means this carbon chlorine bond will break and the chlorine will move out. So, after that, the carbonium that will be formed in this 4 system, which one will be the most stable system? Now, let's do the ionization in this 4 system. Now, if I break down, I have discussed this thing in my second video, I guess. So, if you haven't watched it, you can go there and watch it. I have explained what is heterolytic cleavage. So, in this case, when CCl bond is here, we know that carbon, with respect to carbon, this chlorine is much more electronegative. That's why when the heterolytic bond cleavage will occur, this carbon will come out as C positive, that means carbocation, and this chlorine will come out as an anion, which is Cl negative. Now, we can understand from this that in all of this structure, when carbon and chlorine bond will break down heterolytically, carbocation will be formed and chlorine will go out as a Cl minus. Now, let's do the ionization here. So, when we will move the chlorine out of the system, then a positive charge will generate on this carbon. Again, in this system, when chlorine will move out as Cl minus, a positive charge will be generated in this carbon. In option C, when chlorine will move out, a carbocation will be formed, and in option D, when this chlorine will move out, a positive charge will generate in this carbon. So, I have drawn carbocations of this 4 system. Now I have to start answering that which one is the most stable carbonium ion. Now let's start. In the first option A, the carbocation is generated on this carbon. We can easily understand that this carbon is not directly attached with any other carbon group that contain any hydrogen. So there is no alpha hydrogen. So 0 alpha hydrogen. But the carbocation is present in this carbon, so it can easily undergo resonance with this benzene group. So there will be a resonance that exists in this molecule. Now moving to option B. So in this case, this carbon contains the positive charge, and we can see that there is 1 alpha hydrogen, and 1 alpha hydrogen means there are 1 alpha carbon. So there are 2 alpha hydrogen. But there is a nitro group. Now nitro group is a very highly electron withdrawing group. That means it shows minus I effect. Now because of the nitro group present here, it will try to pull the electron towards itself. Now because already this carbon is electron deficient, when it is attached with any electron withdrawing group or minus I showing group, it will create more electron deficiency on this carbon, and that's how, instead of stabilizing this compound, because of the nitro group's presence, it will become more unstable. So that's why compound B will not show that much stability. Moving to option C. So in this case, this carbon has the positive charge. Now we can see that this carbon is attached with the 2 carbons which are alpha carbon, and that's why it has total 6 alpha hydrogen. So it shows a hyperconjugation because of the presence of 6 alpha hydrogen. But also we can see that it is attached, if we see in the context of inductive effect, also in context of inductive effect as well, CH3 and CH2, that methyl group is known as a electron donating group. That means it's a plus I showing group. So because of the attachment of this carbocation with 2 other electron donating group, it will stabilize the system. So there are total 2 plus I showing group present in this system. Now moving to option D. So in this case, this carbon contains the positive charge, and it is attached directly with the 3 carbon, and 3 directly attached carbon means 3 alpha carbon. So it will have total 9 alpha hydrogen. If we see that in context of inductive effect as well, so we can understand that a methyl group is known as the electron donor group. So in this case, there are total 3 plus I showing group. So from all of these structures, we can easily understand that option D is which contain 9 alpha hydrogen and directly attached with 3 plus I group, that is a donor group. So option D will form the most stable carbonium ion. Now moving to our third question. So it says, what is the hybridization state of the benzyl carbonium ion? So this is the structure of benzyl carbonium ion. So in the previous video, I have explained that in case of any carbocation, it have a hybridization of sp2. So in this case also there is a carbocation, that is benzyl carbonium ion. So in this context also there have been given 4 options, that is sp2, spd2, sp2d and sp3. So we can easily understand that option A is the right answer, which is sp2. So our next question is, the percentage of carbon, hydrogen, nitrogen and other organic compounds are 40%, 13% and 46% respectively. So their empirical formula is, so in this case they have asked the empirical formula. So I have already drawn a table. Now let's fill the table first. So we have given 3 elements, that is carbon, hydrogen and nitrogen, and we have given 3%. So carbon is given with 40%, hydrogen was given with 13% and nitrogen was given with 46.7%. Now let's fill that what is the atomic mass in this case. So atomic mass of carbon we all know is 12, atomic mass of hydrogen is 1 and atomic mass of nitrogen is 14. So After that, they are asking what is the relative number of atoms that exist in this case. So, we have to divide the percentage that has been given with our atomic mass in these three cases as well. So, first I will start with carbon. So, carbon, it has been given with 40%. So, we have to divide 40% with our atomic mass. So, we have to understand when empirical formula will be asked, we have to write this table. This will be easy, and once you are good with it, you do not have to write the table, you can easily understand by looking at the question. So, we have to understand when the relative, in case of relative number of atoms, we have to divide the percentage that has been given of this particular element and divide it with atomic mass. So, in case of carbon, 40 is divided by 12. In case of hydrogen, 13.3 is divided by 1, and in case of nitrogen, 46.7 is divided by 14. So, the answers will be, you can calculate, I have already calculated, so I am writing it just beside this one. So, this one is 3.3. In case of hydrogen, it is 13.3, and in case of nitrogen again, this is 3.3. So, you have already found out the relative number of atoms in this case. Now, next we have to move to the simplest ratio of the atoms. So, in this case, we have to find out that which is the smallest number in case of relative number of atom and divide that with all of these three numbers. So, in this case, among 3.3, 13.3 and 3.3, we all know that 3.3 is the smallest one. So, we have to divide all these three numbers with 3.3. So, let us do it. So, 3.3 divided by 3.3 in case of carbon. Again, in case of hydrogen, 13.3 divided by 3.3, and in case of nitrogen, 3.3 divided by 3.3. So, let us write the answer instead of this. So, 3.3 divided by 3.3, it is directly we can put 1. In case of hydrogen, 13.3 divided by 3.3, it is 4. And in case of nitrogen, 3.3 divided by 3.3, it is 1. So, the empirical formula in this case is C1H4 N1. We do not have to write 1 when there is only 1 is written. So, we can easily write it as CH4N. So, option C is the right answer, which is CH4N. So, our next question says, which of the following statement is not correct? So, the first option says that double bond is shorter than single bond. So, in case of triple bond, double bond and single bond, if we see the bond strength, in bond strength cases, the triple bond is highest, then double bond and then single bond. Of course, we understand that if there is 3 bonds present between 2 carbon, the bond strength will be much more higher than if the only one bond is there between 2 carbons or to any other atoms. So, if the bond strength is highest in triple bond, then double bond, then single bond, the bond length will be shortest in the case of triple bond, then double bond, then single bond. So, our option is the double bond is shorter than the single bond. Of course that is, because double bond has the higher bond strength, that's why the double bond is shorter than the single bond. So, option A is definitely correct. Moving to our option B, it says sigma bond is weaker than a pi bond. Now, we have to understand that how sigma bond forms and how pi bond forms. In case of sigma bond, there is an head-on overlap. But in case of pi bond, there is a sidewise overlap. So, we can understand that in case of sigma bond, there is a head-on overlap, and that's why the bonding will be much more stronger. But in case of pi bond, there is a sidewise overlap. So, there is a sidewise interaction. That's why the bonding interaction in case of pi bond is much weaker than the sigma bond. So, we can understand that option B is a wrong statement, because sigma bond is not weaker than pi bond. sigma bond is actually much more stronger than pi bond. Now moving to option C. Now we have found out that which one is our right option. Option B is the right answer. But let's move to the option. So it says double bond is stronger than single bond. Now again, moving to the first thing, that in case of double bond and single bond, the bond strength is highest in case of triple bond, then double bond, then single bond. And that's why we can easily understand that double bond is much more stronger than the single bond. So that's why option C is the correct. Now moving to option D, it says covalent bond is stronger than hydrogen bond. Of course, it's a right answer. Covalent bond is it's made by a mutual sharing of electron. So a covalent bond is definitely much more stronger than any other hydrogen bond. So option B is the incorrect statement in this 4 options. So option B is the right answer. So our next question is, when the hybridization state of carbon atom changes from sp3 to sp2 to finally sp, the angle between the hybridized orbital. So let's write sp3, sp2 and sp. So in case of sp3, the angle between the orbitals is always 109.28 minutes. In some cases it varies because if there is any steric hindrance or any other space interaction, then the bond angle might increase or decrease, but otherwise in ideal condition sp3 carbon or sp3 orbitals have 109°28' bond angle. Moving to sp2, in this case the bond angle is always 120°, and in case of sp the bond angle is always 180°. So in this case they have asked that when we change the hybridization from sp3 to sp2 to sp, the bond angle, how does it got affected? So in this case we can understand the bond angle actually increases from 109 to 120 to 180. The bond angle actually increases. So there are 4 options. Option A says decreases gradually, option B says decreases considerably, option C says it is not affected, and option D says increases progressively. So of course the option D is the right answer because it increases progressively. So our next question says that a straight chain hydrocarbon has a molecular formula C8H10. Now the hybridization of the carbon atom from one end of the chain to other end are respectively sp3, sp2, sp2, sp3, sp2, sp2, sp, sp. Now we have been given 4 other options. We have to see that which carbon chain hybridization matches with this hybridization that they have been given with the question. So first let's start with first carbon. So it says the first carbon must have sp3 hybridization. So in this case all of this carbon, it's CH3, so all of them have sp3 hybridization. Moving to the second, it says that it must have sp2 hybridization. So the second carbon in this case has sp hybridization because it is directly bonded with another carbon by a triple bond. So it is sp hybridization. So option A is definitely not the right answer and we can cut this out. In case of option B, it is CH2. So it is bonded with 4 other sigma bonds. So it is sp3. So we have been given sp2, this one is sp3, not the right answer. We can cut it out. Option C, it says this carbon, the second carbon is doubly bonded and it has total 3 sigma bond and 1 pi bond. So it is definitely sp2. So this one already runs. In case of option D again, this carbon is doubly bonded. So this is again sp2. Now let's move with the third carbon. It says sp2. Again option C, the third carbon is sp2. Option D, the third carbon is sp2. In case of fourth carbon, it is sp3. So in this case, this carbon is sp3 and this carbon is sp3. So moving to the fifth carbon, it says sp2. So in this case, this carbon is sp because it is triply bonded. So but in this case, option D, this is doubly bonded, it is sp2. So of course option C we can cut it out and our right answer is option D. when we have been given such questions, we can do the elimination type answering, because this is much more easier approach. We can first cut out what is actually not our right answer and then find out what is the right answer among left out options. So option D is the right answer in this context. So our next question says, which of the following possess a sp carbon in its structure? And we have been given all these 4 structures, and we have to find out in these 4 options in which option there is a carbon that is sp hybridized. Now let's start. First we have to understand, in case of sp3 hybridization, a carbon like sp3 hybridized carbon has total 4 sigma bonds. In case of sp2, it has 3 sigma bond and 1 pi bond. In case of sp hybridization or sp hybridized carbon, it has 2 sigma bond and 2 pi bond. Now let's move to answer this question. So the first option says, in this case, let's find out the hybridization of this carbon. This carbon is sp2 because it's doubly bonded. This carbon is sp2, this carbon is sp2, and this carbon is sp2. So there is no sp hybridization. Let's cut this out. Now moving to option B. So in this case there is only 2 carbon. Both are doubly bonded to one another. So definitely both of them are sp2. Let's cut this out. In case of option C, this carbon is sp2 because it's doubly bonded. This carbon is sp2 because it's doubly bonded. Now let's move to see what this carbon is. If we see that this carbon has 2 sigma bonds, and this middle carbon has 2 pi bonds, 2 sigma and 2 pi bonds. Now let's move to this part. In sp hybridization, I have already told you that in sp hybridized carbon, it has 2 sigma bond and 2 pi bond. Now we can easily understand this carbon has 2 sigma bond and 2 pi bond. So definitely this carbon is sp hybridized. So option C is the right answer. Although we find out what is the right answer, let's move to option D to find out what is the hybridization. In this case, this one is sp2, this one is sp2, this one is sp2, and also this one is sp2. So only in case of option C we find out one carbon has sp hybridization. So option C is the right answer. So in next question they have asked, the isomer of a substance must have the same, and they have given 4 other options. Now about isomerism, I have explained it in my last video, that is GOC part 2 video. If you haven't watched it, then you can pause this video and go back to that video and you can see that what is isomerism. I have also explained few other previous year question from isomerism part. Now let's start this. This is a simple theoretical question. It says isomers of substance have the same. First is structural formula, second is physical properties, third is chemical properties, and fourth is molecular formula. Now we all know that in case of isomerism or in between 2 isomers, there is one thing is similar, that is molecular formula. So option D is the right answer. So our next question is, the Cl-C-Cl angle in 1122 tetrachloroethene molecule and tetrachloromethane respectively will be about. So they have asked the bond angle in this 2 system. The first one is 1122 tetrachloroethene molecule. I have drawn the structure here, and another one is tetrachloromethane molecule. I have drawn this structure in 3D geometry. If you want, you can also draw it in 2D geometry. Let me draw the structure for you, this one. So carbon which is attached with 4 other chlorine molecule, this is known as the tetrachloromethane. Now we have to find out what is the hybridization. In this first molecule, both of this carbon has sp2 hybridization. Now we all know from the previous question that sp2 hybridized carbon has 120-degree bond angle. So in this first molecule, it will have 120-degree bond angle. Let's move to the second question. So in this case, this carbon is singly bonded with 4 other chlorine atoms. So definitely this carbon is sp3 hybridized, And from the previous question again, sp3 hybridized carbon has 109 degree 28 minute bond angle. So option, among the options, the option A is the right answer, in which the first one has the bond angle of 120 and the second one has the bond angle of 109 degree 28 minute. So our next question says that the cyclic hydrocarbon A has all the carbon and hydrogen atom in a single plane, and all the carbon-carbon bond have the same length, which is less than 1.54 angstrom but more than 1.34 angstrom, and the bond angle will be, so they have asked the bond angle in this case. So let's start by imagining that what could be the cyclic hydrocarbon A. So they have given few features of cyclic hydrocarbon A. It says that all the carbon and hydrogen are coplanar, means they all exist in the same plane. The next one is that all the carbon-carbon bond are of same length. So in this case, all the carbon-carbon bond length are same. Now we know that in case of carbon-carbon single bond, the bond length is 1.54 angstrom. And in case of carbon-carbon double bond, it is 1.34 angstrom. If you don't know this, then please do remember this two values. Carbon-carbon single bond has 1.54 angstrom bond length and carbon-carbon double bond has 1.34 angstrom bond length. But in this case, they have said that the cyclic hydrocarbon has a bond length, that carbon-carbon bond length, which is greater than 1.54 but less than 1.34. So we can understand that neither the carbon-carbon double bond in the cyclic hydrocarbon are single bond, nor the carbon-carbon bond are double bond. So they must be in between. Now we can easily guess which hydrocarbon they are talking about. It is definitely the benzene molecule. See, this is the molecule that they are talking about, because first of all, this is a cyclic hydrocarbon. Second of all the carbon and the hydrogen in any benzene molecule are coplanar. That means they exist in the same plane. Moving to the second, we all know that in benzene there is resonance. So although in benzene 3 carbon are single bond and 3 carbon are doubly bonded to one another, still they all exist with the almost similar carbon-carbon bond, because in this case, because of the resonance, all of this bond length become almost similar to one another, which is not exactly 1.54, that is the carbon-carbon single bond, and not exactly to 1.34 angstrom, that is carbon-carbon double bond, which is somewhat in between. So we can easily understand they are talking about this carbon A is actually the benzene molecule. Now we can easily understand what is the bond length. So in this case, all the carbon are sp2 hybridized, all the carbon atoms are sp2 hybridized, and we know that in case of sp2 hybridization, the bond angle will always be 120 degree. So option D is the right answer in this case. So today we have completed GOC part 3. We have done few questions from GOC chapter which came in previous year question NEET and JEE. Now I will upload another video on GOC which will be on the qualitative and quantitative analysis of elements in organic chemistry, and that will be the last video of GOC part. And further in future, if you have any queries, you can send me and I can answer them in a separate video. Now thank you for joining me today in this video. I will be very happy if you subscribe to my channel, and please hit the like button. Kindly stay tuned to my channel. I'll upload much more videos on different topics in chemistry, and I'll make it in easier way. I'll try to solve all of your questions. If you have any query, please write them in the comment section. You can also send me your queries in Instagram. I have an Instagram channel also in the name of Chemistry, or you can directly comment here. Thank you.